Okay, welcome back to your next lesson. We finally reached the last part, of the last chapter of your entire physics course. We've covered magnetism in the previous set of videos, and now we're going to talk about electromagnetism. All right, electromagnetism. So in this lesson, we're going to look at the magnetic effect of a current. Okay, the magnetic effect of a current. So this is the learning route map for the entire lesson. We're going to cover what is the relationship between electricity and magnetism, what is the magnetic field pattern of magnetic field due to the current in straight wires and solenoids, how can we increase or decrease the strength of the magnetic field, and how is the magnetic effect of current applied in circuit breakers. Okay, for this video specifically, we're just going to look at the first one. What is the relationship between electricity and magnetism? So recall, in the previous set of videos in magnetism, we talked something about electromagnets already, right? Where when a current flows through a coil of wire like this, a magnetic field is generated, producing an electromagnet. Right, you can see it's attracting these pins. And we learned that we put a soft iron core inside for electromagnets because it gains and loses electricity easily. Basically, we know that when you have a coil, basically the magnetic field, and you align the magnetic domains inside the iron core, right? Then producing an electromagnet. So we know that there's already a relationship between electricity and magnetism. So the question we're going to ask ourselves is exactly what is that relationship between electricity and magnetism, right? And for that, we're going to go a trip down history to learn a bit of the story behind this and the discovery of this. So this all began with a guy called Hans Christian Ørsted. He was a Danish physicist and chemist who first discovered that electric currents create magnetic fields. Right, we're going to look at his discovery today, and we're going to follow the discovery through history. And we're going to, basically, he was the first person to discover that there was a connection between electricity and magnetism. And it's really significant because up till then, electricity and magnetism were two separate things altogether. Right, but because he discovered this relationship, it paved the way for the Industrial Revolution, right? And for all the things that we have today, cars, motors, basically most of our modern technology relies on the relationship between electricity and magnetism. And if he didn't discover that, we won't have most of what we have today. So how did he discover it? The story is actually quite an interesting one. He was a lecturer, I think of a college or something. This was in 1820, right? So that's 200 years ago. He was demonstrating his electricity experiment. So he was showing the class his electricity experiment, right? But I don't know, maybe he was a messy person or something. He didn't clear his working bench, and so he had a compass lying there for absolutely no reason at all, right? It was just because he was messy and it was there. And when he was demonstrating his experiment, he was turning on and off his circuit to show his thing. And then he realized from the corner of his eye that when he turned on and off the circuit, the compass was deflecting, right? Deflecting just means like it was like moving. And then so he was like, was there an accident? And so he tried it again. He's like, it's really moving, right? So it's completely discovered by accident. And he decided, that's interesting. Let me take a closer look at this. And so he was wondering, maybe magnetic effect radiates from all sides of a wire carrying electric current, just as light and heat do. Why is this? What is this question about, right? Okay, so up till then, right, everything that up till then is basically all that you know about physics until now, so far, right? Okay, so if you look at things like forces, right, when you have things that are related, for example, forces and acceleration. If a force pushes in this direction, where's the acceleration? In the same direction, right? And then let's say you have even like say friction is in the opposite direction, but it's still in the same line of action, right? So object is moving here, and then friction is here. It's the same line of action, right? Most quantities that relate to one another or that produce one another are always in the same direction, with the exception of maybe heat, right? So heat, you have an object, and then where is heat radiated? It's radiated in all directions. So these are one of those things where it's not in the same direction. So there were two possibilities. If maybe current was like that, then magnetic field would be like that, or current was like that, and magnetic field is radiating in all directions, right? These were the only two type of relationships that people knew up to that point of time. And that's probably why they never discovered the relationship. But because he noticed that deflection, he kept experimenting and he kept testing. And guess what he found out? He found out that after like 3 months later, he began more intensive investigations, and soon thereafter he published his findings, right? So he found out that electric current produces a circular magnetic field as it flows through a wire. So basically, if a wire is like this, so this wire like this, looking straight through the wire, the magnetic field is actually produced around it in a circular form. Right, and that's crazy because up to then, right, there's nothing that relates one another. So a current flowing this way somehow produces a magnetic field around it in a perpendicular plane. So like it's like this, and then it's around it this way, right? So until then, this is completely revolutionary, and because he did not give up in the experimentation, in testing it, he managed to discover this, and of course, because it was such a remarkable discovery, he won awards for it. He was given a lot of money, and more importantly, it paved the way for much greater discoveries. So very famous scientists down the road that they might have heard of, the French physicist André-Marie Ampère, right? The reason why we have why current, the unit for current is labeled as ampere. He was the guy that worked on his research on so Oersted confirmed that there was a relationship between electricity and magnetism, and he confirmed that that relationship was around it like this. This Ampère guy, he was the guy that came up with a mathematical formula to represent the magnetic forces between current carrying conductors, so on and so forth. Basically, there were people after him that all worked on this discovery, right? Which you won't cover in secondary school science. Right. So what exactly was this guy's experiment? Right. What exactly was this guy's experiment? He basically had a circuit like this. The circuit was open, and when the circuit is open, of course, you expect that the compasses all point to the north, right? So they're all pointing to the north. This is the north direction. They're all pointing to the north. But what happens if the circuit is closed, right? We see that when the circuit is closed, suddenly the one below the wire deflects and points east, and the one on top of the wire deflects and points. This would be west and this would be east. Right, but basically they deflect and point sideways, and so initially, this is still very strange because remember, if you're thinking in terms of all the things that people discovered up till now, you will really be thinking it's either in the same direction, like you would expect it to either go in the same direction as the current, or outwards, right? But now somehow when you put on top and below, it goes left and right. It doesn't make sense, right? And so how exactly does a magnetic field form around the wire? Further investigations, of course, showed this.
A wire that goes through a piece of cardboard here, and I've got it surrounded by little tiny compasses. They're all pointing generally this direction. And I'm going to run current through the wire that will be coming up the wire this way from underneath. So based on the right-hand rule, there should be a magnetic field around this wire. In which direction? Let's find out. So I'm going to clip this on. Now. So it looks like all of the arrows are tending to go around in a counterclockwise fashion from this perspective. I'll turn the current back off. Now I'm going to reverse the current and run it the other direction. So in this case, the current will be flowing down the wire through the cardboard. And let's see what direction the field is there. And now they all seem to be pointing in a clockwise fashion around the wire.
Yeah, so it turns out that the exact relationship is that magnetic field is formed around a current carrying conductor. So in a straight wire, it's formed around it, right? In this way. Yeah, and the reason why I'm emphasizing this again and again is really because this is the first time that you're exposed to something like this, just as it was the first time that Ørsted was exposed to something like this, right? And just as it's revolutionary then, it will be revolutionary for you, and this is a new concept, and you really need to remember this idea that it is formed around a current carrying conductor. Okay, so I'm hoping that this story, right, will not only interest you, but not only teach you about the scientific method, experimentation, and how some things are discovered by accident in the scientific community. Great discoveries can be discovered by accident, but also that this story will help you to remember that it's around a current conductor. Okay, so the magnetic field is formed around the current conductor. Okay, we'll talk more about this idea in a while, but what's the relationship between electricity and magnetism? A current will produce a magnetic field around it. Okay, that's the main relationship that we've talked about so far. Basically, electricity does produce magnetic fields, right? And we'll talk about exactly what this is in the next video.